Okay, hi guys, this is Mr. Krieger, Common Core Geometry. We're going to be doing Unit 8, Part 2, Lesson 5. We're doing proportions in a right triangle, Hills and Sast, second day. And this is video 1 of 2, so make sure that you watch the second part of the lesson. Okay, so again, it's more Hills and Sast. Good practice. These questions are a little harder. So let's take a look at them. In the right triangle EAR, altitude AL is drawn to hypotenuse ER. If EL is 6, EA is 12, then what is the measure of LR? I'll put an X there. Okay, this is a little bit unusual. Usually when we have this in parts, we could use SAS, segment over altitude over a segment. But there's nothing on an altitude. So what do we do here? Well, it's got to be a hills problem. It's got to be hills because there's something on a leg. But the hypotenuse is weird. What it means is you're going to have to add those pieces together. 6 plus x or x plus 6 will work. That's going to be your hypotenuse. Let's remember that hills is hypotenuse over leg. We're going to be using the leg on that side. We'll call it leg 1. Equal that leg 1 again over segment 1. Everything on that side. So what we're going to get is hypotenuse is 6 plus x over the leg, which is 12, equals 12 over 6. 6 is the segment on the same side as that 12. Now when you cross multiply here, we can do it this way so you can see it more clearly. 6 times 6 plus x equals 12 times 12 is 144. And we see that that has to be distributed. If you were to do it without this step, just make sure that you do 6 times 6 and 6 times x. Okay? So now that you have it down here, all you need to do is, it's a simple equation to solve, subtract 36 on both sides. You're going to get 6x equals 108. I'll finish it up over here. 6x equals 108. Divide by 6 on both sides. And you're going to get x is 18. That means your LR is 18. Okay? Not so bad. I'll actually put this here. LR equals 18. It's always good to write down your final answer and box it in. All right, let's take a look at the next problem. We look at this triangle over here. It looks weird. Kind of doesn't look like the triangle we had there. But it does have a right angle, and it does have an altitude drawn. And the reason this looks weird is because it was rotated. And that shouldn't be too difficult for us to deal with. Just rotate the paper if you need. And let's try to figure out, I'll write the number here. This is a 4 and this is a 16 and there's a y on this altitude. And this looks like it's going to be a SAS. So let me call that segment 1. That's the altitude and this is segment 2. This way, when I turn it back in order to write, right side up, I can use my SAS equation with segment 1 over altitude equals altitude over segment 2. And I clearly see what the segment 1 is. It's 4. The altitude is my variable y. You've got to use the same altitude. It's only one altitude. You've got to use it twice. Remember, in all these problems, the numbers or the variables that are in this position have to be exactly the same. So the y and the y here, the 12 and the 12 here. And segment 2 is going to be, we labeled it here, 16. Cross multiply, y squared equals 64. So therefore we get y is 8. The altitude is 8. Okay, so that wasn't too bad. All right, let's go take a look at the next problem. All right, this looks kind of similar and probably not too difficult. So let's see what it says. It says in right triangle ABC, altitude CD is drawn to hypotenuse AB. Now it says DB is 5 more than AD. This is 5 more than this. How can we represent these things? 5 more, does that mean like 5 times something? 5 more than? You got to think that through. More than is addition. So first, since we're talking about dB being some change of something, that means AD should just be a regular old x. And if dB is 5 more than that, We're going to put a 5 plus x there, or an x plus 5. And now it says the measure of CD is 6. Okay? So that's how you're going to represent the lengths of each segment. What do you think this is going to be, Hills or SAS? Well, you have something on an altitude, so it's going to be a SAS problem, which is segment 1 over altitude equals altitude over segment 2, just like the last problem. Let's see if this is any different from the previous problem. So let's set that up. Segment 1 is x over altitude is 6 equals 6 over x plus 5. Let's cross multiply that. It's going to be x times x plus 5 equals 6 times 6 is 36. Distribute that, we get x squared plus 5x equals 36. So this is where the problem becomes a little unusual. What kind of equation is this? This is a quadratic equation, and we haven't done too many of these this year, so you might be like, what do I do here? This is where a lot of my students get stuck, because it's been like you were good at this in algebra, but it's been a while since you solved an equation like this. The first thing to know is when you have a quadratic equation, especially with 3 terms, make one side equal to 0 by subtracting 36 on both sides. Okay, so that's the first step. Next thing you got to do is you got to say, well, how do I solve this? This is where factoring comes in. I'm going to do the work over here. We have, and I'm not going to do the equation, I'm just going to do the trinomial. Let's remember how we would factor this. The factoring requires you to find 2 numbers that multiply to this number and add up to this middle number. So we're going to make a table. Some people like the table, some people don't really need a table. The table will allow you to find all the numbers that multiply to 36. So like, for example, 1 and negative 36, that works. Also negative 1 and positive 36 works. You could get 6 and negative 6, that multiplies to negative 36. You could try 4 and negative 9. You could try negative 4 and positive 9. And then there's other multiples, 12 and negative 3, negative 12 and positive 3, and there's possibly even more. But let's put them in. How about 2 and negative 18, and negative 2 and positive 18? I think we've exhausted all the possibilities here. Let's see, we got all the numbers that multiply to 36, but now we need numbers that are going to add up to 5. Well, 1 and negative 36 adds up to negative 35. This pair will add up to positive 35. This pair will add up to 0. This pair adds up to negative 5. Oh, let's check. We need a positive 5. Well, negative 4 and positive 9 does add up to positive 5. Those are going to be the pair that you need. So how do we finish this up? We make 2 sets of parentheses. We put an x in each parenthesis, and we take the negative 4 and the positive 9 and put a plus 9 there. And now we can make a t-chart and solve each of these mini equations. Make them both equal to 0. Add 4 to both sides. You can get x equals 4. And that's a possible answer. Let's see about this one. Minus 9, x equals negative 9. Well, that's not a possible answer. Why not? You can't measure the length of something with a negative number. So we'll call this a reject, thankfully, because we don't want 2 possible answers. And here's our one answer. So what do we want to answer? Find the length of AD. AD equals 4. That's exactly what we needed. I'll box it. And that's how you solve this more complex equation. And I'll be doing a second video that has the rest of the lesson.